Hey
Yay!
everyone.
Hello. Good morning. Morning, right?
Yes, it is
Yes.
morning. Yes.
Okay. What is time?
Uh, oh, I slept so bad last night. I barely got any sleep. So today's puzzle
Oh
is gonna be
no.
fun. You can watch me just like fail to remember how to type.
I feel like that was me yesterday, so that's great.
It happens. Like I had that on, was it day three or something, where I just like my brain just totally shut down.
Yes.
But today we are on day six. So let's have a look. All right, lanternfish. The seafloor is getting steeper. Maybe the sleigh keys got carried this way. A massive school of glowing lanternfish swims past. They must spawn quickly to reach such large numbers, maybe exponentially quickly. That is never a good sign.
Mm-hmm.
Exponential growth. You should model their growth rate to be sure. Although you know nothing about the specific species of lanternfish, you make some guesses about their attributes. Surely each lanternfish creates a new lanternfish once every 7 days. They're asexually reproducing lanternfish. I remember reading about, is it lanternfish or anglerfish where they reproduce by the males are actually really tiny and the females are the ones which have the big like lanterns on their head, and the male bites onto the side of the female lanternfish and gets absorbed.
What?
Yeah, yeah.
What kind of
I
horseshit is that?
do I have to look this up now?
No.
Oh, this is not. That's a different thing. Okay, lanternfish are not the same as anglerfish. Okay, so
It's a safe
these,
for work stream, please.
yeah. How do they do lanternfish asexually reproduce? And oh, not to be confused with anglerfish, which have lanterns on their forehead. Anyway, moving swiftly on. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another lanternfish through some as yet undisclosed means. Um, while another might have four. So you can model each fish as a single number that represents the number of days until it creates a new lanternfish. Furthermore, you reason that a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish, 2 more days for its first cycle. So suppose we have lanternfish with a timer of 3, then it goes 2, 1, 0, and then flips back to 8 and creates a new lanternfish with a timer of 8. Sorry, flips back to 6 and creates a new one with a timer of 8. Okay. New lanternfish creates a new fish. A lanternfish that creates a new fish resets its timer to 6, not 7, because 0 is included. So 0 to 6 inclusive. New lanternfish starts with 8, does not start counting down until the next day. All right. Realizing what you're trying to do, the submarine automatically produces a list of the ages of several hundred nearby lanternfish. That's many fish. Your puzzle input. For example, suppose you were given the following list. This means the first fish has an internal timer of 3, then 4, then 3, then 1, then 2, so on. Okay, so it's a simulation. Every day you run a step of the simulation. You decrement all of the ages. If any of the ages falls below 0 or was 0 at the start, then you create a new lanternfish and you go forward. In this example, after 18 days or 26 days, after 80 days, there would be many, many, many. How many lanternfish would be after 80 days? Okay, so how this thing tends to work in Advent of Code is as soon as you see this, that it's growing exponentially, you start to worry. Um, because what the person who writes these tends to do is give you a puzzle which seems like, okay, yeah, we can solve this. We can have a vector of these numbers, and we decrement all the numbers and then create any new lanternfish. And that might work for up to 80 days. But my guess is the part two is going to be exactly the same as part one, but instead of 80, it's going to be like 8,000 or something. And if it's exponential growth, then storing all of these numbers after 8,000 days is going to be intractable. Like it's not gonna happen. Halo Corn, how's it going?
Yes.
So usually there's a simple way of doing it, which is, as I just said, store all of these in a vector, decrement, create new ones. And then there's a smart way to do it, which will actually work for the larger number of days. So I think the smart way to do it here is you don't need to store every fish. You only need to store the count of fish for any given timer value. So we have a counter for the fish of who have 0 days left, and 1, 2, 3, 4, 5, 6, 7, 8, and yeah.
Those counters, I feel like in some programs they're also called buckets. Do you think the author of Advent of Code was thinking about fish buckets?
The fish buckets, yeah.
Anyway.
All right.
Yes.
You ready to go, Josh?
I'm ready. Good luck.
All right.
And I'll see you midway through, hopefully.
Yeah.
Gosh, only. Okay. Yes. Hey. Hey, everyone. Oh. Hold on. I was like, what's wrong with my sound? And my headphone was like weird, but it had like noise cancellation on. So I was like canceling myself out. I was like spinning around. Figured it out. All right. So today's problem is fish buckets. We got to create buckets of fish. So right before this, I copied over the little template that we have here into day 6. So if we cargo check. Ooh, what's going on? Oh no. Cargo clean. Cargo check once more. Let's see what's going on. Okay, day 6 does not have day 6 input yet. We can create that there. 6.txt. Let's run this once more. Cargo check. Now it seems to be mostly getting there. Cargo test dash target. No. Lib. I don't know how to do this. All right, let's run this first test. Doesn't do anything. What did this run? Cargo test package bin day 6. Cargo T there. Oh. Sorry, I'm just running the test command once. There we go. Okay, we have our tests running and failing, and that's okay. So we have our first little test input here, right? 34312. So that's our input there. And then we have 18 days. There are a total of 26 fish. After 80 days, there would be a total of 5934. Let's do that. 5934 right there. Parse 1 input. How many lanternfish would there be after 80 days? All right. So what we need to do is step 1. We need to like parse our input, right? So our initial state is essentially we will have 9 buckets, 1 for each day. Each bucket contains an increment, I guess, or like a counter. And then we can have like a little step function that says like step 1, step 2, step 3, and that like changes the counts. And then a count function. So I think we want to create a struct. Hold on, I need to remove things. Oh, that goes. Okay. Accidentally left one thing open. Okay, here. Let's take a look. So, also, hey everyone, how's it going? How are people? If you're in chat, say hi, introduce yourself. If you've solved this before, please share your answers. We can take a look at it after stream. Well, not after stream, at the end of the stream. All right. So s dot split by that for num in s dot split, or I guess we can we do this? Nah, I don't want to do this. Let my buckets. Oh, we said we'd create a struct of buckets. Hey, Cutter Benson. Yeah, thanks. Hope you had a good weekend as well. My weekend was quite nice. My partner just came back from Canada, so that was great. Having someone else around after having been just me and the cats for a month. So yeah, I'm pretty pleased. What do we say? Buckets, and this becomes a U size 9, so we have 9 buckets. Impl buckets fun insert. What do we say? Mute self index U size there. Self dot buckets index plus equals 1, I believe. Fun step. Mute self. And then we're gonna have like count self U size. Yay, thanks for sharing your solution. We'll take a look in a bit. So our insert is insert a fish into the thing. A step is like step like once. This will like add a day, so if we have like 80 days, we say 80 steps, right? And then count here, count fish. Insert fish. Oh, bump. Closing that too. Hey. Cool. All right. Self buckets index plus equals 1. Step day. Count fish. 2, 2, 2. Good. For number in s.split. Yes, and let's add a new function here as well. I'm taking my sweet time, I guess. 09. Let my buckets. Oh. Num.parse.unwrap. Does that work? Method not found in buckets. Insert fish. There we go. So now we have like for each number, we insert 1 fish into the corresponding bucket. Let's do a derive debug buckets right there, and let's run this. So here we can see bucket 0 1 1 2 1. So our input is 1 1 2 1. That makes sense. Let's verify that the input is correct. 1 day 3 4 3 1 2 2 3 2 0 1. All right. So we can like do our step function. We can implement like count fish first, which is probably the easier one. So here we say self dot buckets dot iterate into iter dot sum. Does that work? Yeah, that works. Count fish. And here the answer is like total of 26 fish. Would there be after 80 days? So here at the end, we can say buckets dot count fish. That's our answer. Value borrowed here after move. Oh, like that? Better? Good. And now we just need to implement like our step day function, which will be, we're gonna like rotate our thing once.
Hey Josh, we're done with part 1.
Oh, whoa. Hold on, that was the
I
voice
was right.
Hello. Can you hear me?
Yep.
Yes, fantastic. Okay, great. We're almost done. We're like implementing the stepping function now.
All right, cool.
But you're saying part 2 is indeed like exponentially more?
Yeah, it's just exactly the same, but with 256 instead of 80. So like if I just save this and run it, I'll probably get the answer in the time that we're talking.
Oh, amazing.
Oh no, I didn't. I overflowed something. I guess I need ULL here.
All right, I'm going to like continue stepping. If you're like done like in the next like 5 minutes, do you want to like join my stream?
Yeah, I just got it. We're done.
Oh, okay. Sick. Hold on, I'll screen share. We're like not far off. It's kind of cool like how the bucket solution pretty much just straight up worked.
Okay.
I'm
just gonna very quickly clean this up a little bit.
Okay, I'm screen sharing. We spend a little bit of time like creating a fancy structure and like making it look nice with good methods. Oh, muting myself until you're here. All right. So we need our stepping function, which becomes essentially like a rotation, right? Let n equals self
right?
dot bucket 0 times 2. That becomes like our 8th index.
All right, let's go join Yosh. I'll fix that in a bit.
Hey.
Yeah, Metro Roboter U64 is enough. You don't need any more than that. All right, so how are you doing, Josh? Does Rust not have a array rotate?
Maybe it does. I mean, I haven't like checked, so let's check. Do we have array rotate? No. Okay. Do we have it on slice? Because I was thinking of it, but I didn't know if we had it. Oh, would be on. Would be on slice, right? Slice. Rotate left. Sick. Oh, yeah. Okay, perfect. That's exactly what we want. Right? Yeah. So let's take a look. A dot rotate left 2. Yes, exactly. Okay, hold on. We're gonna redo this. Self dot buckets dot rotate left. Wait, what does mid mean?
Mid is presumably the point which is now going to become
Oh, okay.
the beginning.
Let's take a look.
So you want mid to be 1.
Okay. And then we do self dot buckets 8 self dot buckets times 8 times 2. That would be it.
No, so you're rotating your buckets, right? So the ones which were in 0 are now going to be 8.
Yes.
So that's creating the new ones, but then your old ones don't want to be timer 8. Your old ones want to be timer 6.
Oh, yeah, that is true. Oh, wait, hold on. Reading this. So.
Hey, Walter.
Oh, hey, Walter's also in my chat. Hey, Walter. So what do we have here? 3210. Wait, that becomes 1.
You just want to add the 8 bucket into the 6 bucket. That's all you need to do.
Okay. Wait, do we still multiply or not?
Because your 8 bucket, no, because your 8 bucket now contains the correct number of new fish.
Right.
So you just need to make sure that you put the
like that
the fish into the yes, exactly.
Oh, okay, I see. That makes sense. Cool. For in 0080, let's see if we're like off by 1 on this one. We say buckets dot step day, and then buckets count fish. Let's run this unit test right here. Okay, that worked. Let's take it with the input.
Nice.
Run. So day 611 parse int error kind empty. S dot split.
Did you paste your input into?
No, I didn't. That will do it.
That would explain it.
Yes. There we go. Perfect. 10 out of 10. Error value. Invalid digit. Well, we can dbg it. No, hold on. We can dbg that. Let's see what it is failing on. And people are saying, please use trim. And they're like, right. Yes.
You've got a new line at the end.
Yeah, we can trim that, I believe. Panic that not yet implemented. That's good because that's our second run.
Part 2.
Yes. Okay. Output 1. Let's take a look. Submit. Yay, 1 gold star.
Nice.
256 days. Yeah, cool. Let's take this, copy and paste that into our parse 2. So that's 256. 256. Step day count fish. Run test. Oh, hold on. I forgot that we're missing a little variable there. Gonna move this function right under our first function. Let's run this again. Oh, or let's run this test. Yay, both tests pass.
Yay.
Which means we can now run this. Yay. Submit.
Big number.
Ta-da. Done. Yay. That was a fun one.
Nice.
25
Yeah, that's pretty
minutes.
quick.
20 minutes. That was great. Yay.
You know, kill your screen share so that I can get us back on my stream.
Yeah. Or we can look at your solution first, and then we can... No, I'll stop screen share though.
Cool. Yeah. I'll push mine to GitHub so you can have a look.
Yes. I'm really curious.
Let's just stage all of this. All right, pushed.
Yay. Let's take a look. Did you end up using the string split?
I did. Yeah.
Oh, amazing.
It was much nicer than the old method I used of doing the split and then having to parse it by hand and everything. Yeah, this is much nicer. This solution looks pretty nice, I think. It's pretty much exactly the same as the Rust one, to be honest.
Just it's like really funny to me that line 9 says autofish. Someone who doesn't write C++. Oh, cool. Okay, so you split your string into fish, then you create 9 buckets, and then for fish and fish, buckets F++. Wait, what the? Huh? Oh, I see. That the plus increments the bucket count. Yeah, I see. Walter says, friend of the turbo fish, I presume. Yes, exactly.
Yeah, and then they just do a rotate and a cop and a addition and then an accumulation at the end, and we're done.
Oh, yeah, perfect. And then you have your part 1, your part 2, and your main function. Yeah, that's perfect. How much different was this?
Not very different from your solution, to be honest.
That's the same. Yeah, I guess the main difference is I create like an object-oriented thing where I had like a structure named buckets rather than like inline. But like our main logic, the rotate left and then the increment the buckets by the other thing, that's exactly the same. Amazing. Yay. Cool.
Well, that was a shorter one today.
Yes.
We'll be back tomorrow. See how we do.
Yes.
Hope y'all have a good day.
All right. Thanks, everyone.